So everybody should know Professor Bob Twiggs with the CubeSat. It has been a great opportunity for people that didn't have satellite experience to be able to reach space. We've been doing it since 1969. Actually, it was 1970, right? AO50 launched in 1970. No, AO5 launched in 1970. So what a great opportunity for so many universities, high schools, and just clubs to be able to place a satellite in space. And a lot of that is due to the CubeSat form factor, which we have Professor Twiggs, thanks for coming up with. And then also tonight we have Nick, who will be joining us. So if you'll give him your undivided attention, I'd greatly appreciate it. Thank you.
Well, I've been associated with AMSAT for quite a few years, but normally I don't get an audience to talk about satellites, that there's more satellite knowledge here than I could ever pretend to have. I do want to say that it is a pleasure, and I think really AMSAT has set the standard for satellites and getting into satellites. As you see here, I've got Nick's name and my name. Nick and I are working together on a little satellite we call SlimSat, which is closer to a Sputnik than it is anything else. It doesn't have much power. But if you'll notice here, I have a previous call sign than the one I have now. I went to a number of ham meetings, and before I got my call sign, and so I would use this one, STUPID. And mainly it was because there was a little thing that required you to have, even for the novice license. It was the code. And I never got through the code, but when they dropped the code, guess what? I was able to get my license, and thank goodness for that. But we've got Nick with me here, who I really appreciate working with. Small satellites. Let's see, come on, oh, wrong one. How about this? Anybody remember what that one is? How many in here listen to that on your radios? Oh, we got a few of them here. Yeah, I understand that that was the hams, that was what it was transmitting at. So, and that doesn't look like a small satellite to me. But we got a small satellite that the U.S. had, right? Does anybody remember that one? Ah, that is the first one, which now resides in the Air and Space Museum in Washington, right? The rocket blew up on that thing and tossed it out on the ground, but it worked. It went beep, beep, beep. And you can see that if you go to the Smithsonian. The antennas are a little bent on it. But then there was another group here that was in the background. It's really interesting to me if you read about Eisenhower and the politics that went on with respect to these satellites. Does anybody remember what that particular satellite determined when it was launched? It's determined the Van Allen belt, right? We didn't even know we had a Van Allen belt. So to me, one of the very interesting things is the Van Allen belt. That thing is up there, the magnetic field catching electrons and protons. And the other little thing is there's a place called the South Atlantic Anomaly. Why is there a South Atlantic Anomaly? You know, I went many years in lectures to students, the South Atlantic Anomaly, and then they'd ask why. Finally, I found a guy that told me, because of the magnetic field, the way it's shaped, it's in over the South Atlantic, the magnetic field comes down much lower than it does anyplace else. And that's why, because these electrons and protons, they go zip over here and then they go back zip over there. They're going back and forth and they go down real low there. So, you know, that's pretty cool. The space environment is, to me, is a cool place to talk about. Not so cool to design to, but at least a cool place to talk about. Okay, so I'll just give you a quick rundown on where I've been, and finally I got kicked out. But I started at Weber State University about 10 years in industry, and I moved to Utah working for a company called TRW, and then got invited to come up to Weber State to teach. And it really turned out to be a good move, or a fun move in my career. But while I was there, the FAA come around and said, we want you guys to build a satellite. And from that, we actually built our first satellite called NewSat-1, got it launched on the space shuttle. Then some guys from AMSAT come around and said, hey, we're going to build some satellites. If you'll help us, we'll give you one of them. So we happen to have a manufacturing engineering department at the school with good CNC machines, so we ended up building all of the structures for the satellites, of which one of them was WeberSat. We got it launched, and then in 1994, I had raised enough trouble at Weber State. They said, maybe you better go someplace else, so I went to Stanford University, building microsatellites. And I had a problem with the students, which I'll tell you about, but we actually, the microsats turned out to be too big. And then the CubeSat come along. It was a new way for students to launch satellites. In 2009, I moved to Morehead State University. I retired from Stanford, and like the rest of you, you don't stay retired too long. So I went there, and that's where we got our first pocket cubes launched, and then we got some satellites called ThinSats launched. So let me go on with that. 1980, there was a guy named Charlie Bonsall, was an engineer for the FAA in Salt Lake City. And Charlie says, we've got a problem. And he went to a guy named Gilbert Moore, who worked for Morton Thiokol. And Gilbert, of course, Morton Thiokol was building the motors for the shuttle. And what the problem that they had was, with their antennas that were near the airports, if they got tilted up too high, airplanes could fly under them. If they got tilted too low, then you got reflections off of the ground and the antenna, and they'd get lobes in them. So he wanted a way to characterize what these antenna shapes looked like so they could adjust the antenna. So what he come up with is he wanted a satellite that when it flew over, it would send a signal down and they could calibrate their radar. So Charlie come along and he said, okay, we need a satellite, Gil. And Gil says, why come to me? And as from a government agency, Gil says, we got no money. So we went to Gil to get a satellite, and Gil says, well, maybe we can get some students to do it. They're really cheap. And so Charlie says, all right, let's do it. Charlie says, we need a launch. Gil says, why me? Charlie says, we got no money. And so Gil says, well, how about we put it in the getaway special can on the shuttle? And that's a can that actually Morton Thiokol had developed for experiments to be flown, especially for students. And then Charlie comes back and says, all right, who's going to build a satellite? And we got some students. We'll find a university and someplace here in the state. So they got the University of Utah, very prestigious school. But after 2 years, University of Utah says, no results, too hard for our students to build a satellite. So got together again and they said, oh, let's take it up to Utah State, preeminent space university. But they said, sorry, we can't take that on. It's too difficult for us. So what did they do? They come to a little school that I was at called Weber State, and it's a technology program. It isn't an engineering program. So they come to us and said, at Weber State, we said, wow, this sounds like fun to us. Let's go do it. Technology program. Okay, so in reality, we faculty didn't know what we were getting into, to tell you the truth. But we got people together. We got the faculty. We got close to Hill Air Force Base, and we got a bunch of hams from out there to come in. AMSAT, we had a relationship with AMSAT. And anyone else that was interested, come on, let's go build a satellite. And we got it built. By 1984, we had a satellite built. And that's what it looked like. Does that look like a regular satellite to you? That thing weighed about 100 pounds. And we were going to launch it out of the getaway special can. And so what you want to do is you're going to launch something, it's going to stay up. You want it to weigh as much as possible, right? So that's what we come up with. There was this satellite here. Gilmore from Utah State University got in on the group. Rex McGill, back up. Rex McGill, myself, and another faculty member, and we got a lot of students involved. So Charlie Bonsall did the thermal test on it. Of course, this is the cold test. I don't know whether that's an accepted way to do the cold test or not, but it worked. And look at that satellite. That is a mess. That, you know, did you ever see so much wires running in the wrong direction? Well, they were in the right direction because actually it did work. But the way that thing was built and what was in it, if NASA knew, they would have never flown that thing. It was terrible. You know, you ham guys are really innovative. They got a board that was the transmitter and the receiver, and it turned out to be a board probably about 12 inches long and about 4 inches wide. Well, it turned out that the cage that was on this thing, this guy, one of the engineers tried to find a place to put this in there. He couldn't get it in. He tried for about a half hour. But as hams do, he found a way. He found a hacksaw. And that guy took that board and cut it in half with a hacksaw, folded it over with some insulation, and it runs some jumpers on it, and it worked. Okay? Not NASA qualified. So, you know, what they did was, it was really amazing. And, you know, hams, when you design something, I know that all you ham engineers can design it so it's right the first time, right? We had one young lady working with one of the engineers, and he gave her a design that he come up with and showed her how to build it, and she built it, and it didn't work. So he modified it, give it back to her. She fixed it. It didn't work. It went through about 4 iterations like that. And I come in the lab one day, and she was just sitting there crying. I said, "What's the matter?" She says, "Well, he's designed that thing 4 times and it doesn't work. I thought engineers could do it the first time." So anyway, they got a lot of education they didn't expect. So there's the gas can. And one of the things that NASA had to do was it had a lid on it that opened up. They actually had to redesign it for this satellite. They had to have a full opening lid on it and build a launcher for it. And you can see here what the launcher was. As that bolted down, there was a clamp band around it, and when you released the clamp band, then there was a pusher foot that pushed it out. So, and you can see our ground station there, very high-tech Apple II. But it worked. It was good. I couldn't get anybody to give me an IBM computer at the time, but we found somebody that'd give us an Apple. Well, we took that to a place called Goddard Space Flight Center. Who in here ever worked at Goddard Space Flight Center? Yeah, Frank back there. We knew Frank. So we took it there for an inspection to put the solar panels on, and it was very interesting. We got there, and the 2 astronauts that were going to fly with it were there, and some other people. And I have to tell you a story. I don't know about a lot of the professors, but when I found working with students, they would work on the satellite, but they wouldn't let me touch it. So what I did before we took the satellite from Weber State, I snuck in the room where the satellite was, and I put my finger all over it. I was bound to get my fingerprint in space, whether these students wanted it or not. I need to tell you another story here about going to Goddard Space Flight Center. My job when I got there is I had to take one of the panels off on the bottom where the fuse was. And the guys were scared if we put a fuse in there and the fuse blew, then the satellite would quit. So they had me do a special technique, wrap wire around the fuse holder. And they said, for heaven's sakes, don't let anybody look inside of that satellite or they won't let us fly. So I was bent over this table and I took that panel off and I looked around, there's nobody here, and I laid the thing down and I got the wire and started wrapping around it, and I happened to look down between my legs and there's a camera, a TV camera between my legs looking inside the satellite. And I thought, oh, they're going to kill me if they see those pictures. So I put my hand over the front of the camera, and I got one of the Goddard guys to come over. Get this guy out of here. Get this guy out of here. And after he left, then I could put the panel back on. But that was the only time I think I was on TV with a camera between my legs. So anyway, we got the thing put together, and then we went down to Kennedy, and let me back up here. And I have to tell you another story. When we were up at Goddard, these NASA guys like hats, right, Frank? If you can give anybody hats, it's really a good deal. Well, I had brought 6 hats from Weber State to give to people, and when we were at Goddard, I handed the hats out to all of the NASA guys, and then the astronauts come along, and I said, ooh, I want to get a hat to one of the astronauts. So I asked a couple of the NASA guys, could I have a couple of hats back? I want to give them to the astronaut. And they said, sure, but. And I thought, oh, well, it can't be too bad. I'll have to get him 2 more hats. He says, I'll talk to the guy, I got it from the NASA guy, I'll talk to you later about hats. And I said, okay. So they give me the hats, I give them to the astronauts, everybody was happy. But before I left, that NASA guy cornered me. He says, I want you to get some more hats from Weber State. I said, okay, how many do you want? 60. 60? I'm going to have to go to the president to get money to get 60 hats. And so I did. And so I had a suitcase full of 60 hats that I took down to Kennedy with me. And well, we got in the little building to integrate the satellite, and the NASA guy come up to me and he says, Bob? I said, yeah. You got those hats? I said, yeah. So I went and got the suitcase and I give it, and he disappeared. Pretty soon he come back with my suitcase, empty, and I have no idea where all those hats were. So you got to be careful with these NASA guys. So these are the astronauts. We were on the Challenger. Fortunately, 1 year before, we lost the Challenger. And the group of astronauts, there's Don Lind was an astronaut that was in charge of releasing the satellite. And so we told Don, when you get up there and release that satellite, please take some pictures of it. Because in the gas can, we had tied the antennas down. So they're not supposed to touch the edge of the gas can. We tied them down with fishing nylon, like everybody does for antenna tie down. And we said, we want to know when that thing is released, if the computer boots up, it'll release those antennas. So watch for the antennas to come up. Well, they launched, and Don Lind forgot to get his camera. But apparently he grabbed it just quick enough to take one picture. Look, the antenna come out. Oh, we were so happy. At least the computer runs on it. Really made us happy. And then we got at our ground station. You can see the crew there. We were in the control room on a evening on Thursday night. They launched it on Monday, and we didn't have our ground station ready yet. So we finally got our ground station together Thursday, got it working, and we looked at the pass time, and they said, oh, we're going to have a pass here about 8 o'clock tonight. Let's see if we can contact it. But the PR department and the president said, we do not want you to contact it until the press is there. The first time it comes on, we want the press there. But we said, should we do that? Everybody looked at each other and said, so they sent a signal up to it, and sure enough, that thing answered back. And we were just so happy. Then there was another pass on Friday about 6 o'clock when all of the local TV stations were around, and they come to watch us contact our satellite the first time. Guess what? No response from the satellite in front of the TV. So anyway, I'm sure none of you have had that kind of problem. Anyway, the students got some real good experience there. So it operated for about 20 months. It was on a fairly high inclination, the highest inclination that the shuttle could go, and a pretty high orbit. It stayed up for 20 months, then come down and, like most of these do, splashed in the ocean. So give you a little history of the satellites that I've been involved with. Was we got this one launched in 1985. We got CubeSats. We got them launched in 1990, 4 of them. Cool, on the Ariane. You know, the U.S. is so interested in launching little satellites, we got it launched on the Ariane. So about 1998, I was at a conference in Hawaii, and we had a bunch of Japanese students there, and we were talking about satellites. And I was giving a presentation. I had a can of Coke sitting on the thing, and somebody says, well, you know, is there a new kind of satellite that we can do? And I looked at that Coke can, and I thought, wonder if we can build a satellite in a Coke can. So I held the Coke can up, and I says, anybody think we can build a satellite and get it launched in this Coke can? There were 3 Japanese students stood up and said, can do. So that's where the CanSat come about. And I don't think any of them been totally launched into space, but it's a big program in Japan with CanSats. In Europe, they're big. There are a few of them in the U.S. So along 1990, just as the timeline was when we come up with the CubeSat, started work on the pocket cube. Why did we want a pocket cube? Well, these guys that we first launched cost us $30,000. Then, when it got popular, they raised the price to $90,000 for a CubeSat. So I was trying to find a way to launch something, a little satellite, and I thought, well, if I can take the room of a CubeSat And if I can reduce the satellite size, if it can go from 100 centimeters down to 50 centimeters, which is a 2-inch cube rather than the 4-inch cube, I can put 8 of them in there. So I said, that's what I'm going to do. If I can do that, if they charge me $90,000, I can divide it by 8, right? So I started working on that. It took me a little while, but then I got to Stanford, and in 2000 we launched a satellite called Opal as a microsatellite. And then we launched another one called Sapphire in 2001. And then we launched another one of the first ones that was launched, the CubeSat, was a 3U called QuakeSat. And then 2016 we come up with the idea for the ThinSat, and we launched 60 of those in 2019. We launched another 30 of them in 2021. So just to summarize this is the new Sat-1. You can see the launch platform on it. This is the WeberSat. There's the students with the WeberSat. And we added a little section on the top of it and actually put a camera in there. And here it is on the Ariane 4 on the ASAT platform. We got it launched, and there's the first picture. They actually took a picture with this thing. Now, if you look real carefully, up near the top of the picture, there's a road with a car on it. Everybody see that? Nobody sees it? Well, maybe we should have amplified it a little bit. But that was the first picture we took. There's a whole story about that. We put the camera in there to take pictures of the Great Salt Lake. And, of course, you AMSAT guys went and put magnets in it to orient the satellite. Nobody ever told us what the magnetic field really looked like. By the time it got over Utah, it had tilted enough in the magnetic field. All we could see was the horizon. So planning ahead, that's planning ahead. Okay, CubeSats. Have there been any CubeSats launched? Quite a few. The last time I looked, they're projecting almost $6 billion worth of CubeSats or small satellites by 2030. So I think it got popular. Here's a satellite that we built called Opal. And Opal had an interesting payload. Its payload was actually to launch little pico satellites working with the Aerospace Corporation. And those pico satellites were about the size, I call them the size of a Klondike ice cream bar. Students went through all the work on it. So here's what the launcher looks like. It had 4 launcher tubes in it. And so we launched some amateur satellites for Aerospace Corporation, and interesting. We learned an awful lot about that. So anyway, here's Jamie Cutler, one of our key graduate students that worked on that, working on Opal. And Randy, that probably looks familiar. Randy here, raise your hand, Randy. He's responsible for the group that built the JawSat that we were hooked onto. And we launched on Minotaur, which is a converted ICBM launcher. Very interesting. They built this platform to launch the Minotaur, and apparently it was a really low-funded program. They used a John Deere tractor to pull it out of the assembly building there and to pull it out to launch it. And they had problems with it heating up, so what they did is they put a styrofoam cooler on the side of it with a hose running through the styrofoam cooler to keep some of the electronics cool in it. So, you know, I didn't know that they had things like that, you know. And we had a little antenna at Stanford. There's the feed horn. If you've ever seen that antenna, that's a pretty big antenna. In fact, it's so big that the control room rides around on some railroad tracks with the antenna. And so that's what we used to contact it. And we had another satellite that we called Sapphire that the students had built. We finally got that launched. It got launched on a rocket from out in Alaska from Lockheed Martin, and we had a camera in that one. Now, that one, can you see the roads down there? I think there's some roads there someplace. Anyway, it took a picture, and that's quite a bit. You know, you're talking about wanting to put cameras in your satellites, right? Well, we did it a while ahead, so, and it worked. And then we got a satellite called QuakeSat, and that was an interesting satellite. We worked with a company there in Palo Alto that their main thing was to try and predict when earthquakes are going to happen. But we never have any earthquakes in California, right? Few of them. Anyway, we built this satellite, and what it was looking for was the RF energy, the spectrum, some of the spectrum energy that they think is transmitted out in on an earthquake before it happens. So it's an earthquake predictor. They actually did pick up some data with this thing. So it was launched on a Russian rocket. Here the students are in the ground station there on it. And then we wanted to find a way to launch some satellites, and we knew some guys at Orbital ATK, and I had a little 2-inch cube, the pocket cube, was trying to find a way to get it launched. So I caught Warren Frick, who's one of their PR guys, up at the Small Satellite Conference, and I'd heard about you could put something on the second stage. So I asked Warren, I said, Warren, can we put these little pocket cubes up on the second stage of the Antares? And I'd asked him so many times before I had to back up because I thought he was going to swing at me. But he said, no, I think we've got a way. So the neat thing about it, within a month, we actually was at Orbital ATK working on putting these things on. And what we ended up, as you can see the second stage there, we got some things, a different kind of launcher than the Peapod. It was called a canisterized satellite deployer, CSD, from Planetary Systems. And that's what it looked like. But instead of launching little 2-inch cubes, we decided, why don't we launch something like this? Why don't we launch it, and we called it a ThinSat. So the idea was to launch as many separate satellites as you could. And so this is what we come up with. And that's what the frame on them looked like. They fit together and mashed them up. And the original thought was, as we wanted to hook them together with nitinol wire, and that wasn't accepted very well. So this is what they looked like put together. And what happened is they hooked them together with some solar panels, and these actually worked. We had a Global Star radio on them to talk to the Global Star. They were launched in 2019, and unfortunately our 5 days to a week orbit turned out to be 2 days before they came down. So we didn't get a lot of data out of them, but we got a lot of education out of them. You take 60 of those satellites, and all the schools that worked on it was a lot of education. So we got another group together, and we want to launch 30 of them. But we had a slight problem. None of them worked. The guys that built them for us decided it would really be nice to improve the power system. It turned out they improved it so much it didn't work. So we launched 30 dead satellites. Students still got their education out of it, so you never know. So this is the one where the CanSat come up, and you see these Japanese students thinking, hey, we can do this. And what they did is, instead of putting them in space, we got together with some high-power rocket guys that go out to the Nevada desert every year and launch these high-power rockets. We put them in a canister like you see there. You could put 3 of them in. That went up in the top of the rocket, and the rocket went up 2 miles and kick these out, and they come down on a parachute. Really a lot of education for the students, and a really good program. It's still going on. So why did the Pocket Cube come about? Because the launches got too expensive, and so we had to get a new launcher. So I built a new launcher, and actually didn't have to go on the Peapod with it. We were able to put these launchers on a Italian satellite, and you can see, I think there was three of them on there. You can see the blue things on the top. And they actually flew again on a Russian rocket and got launched. This is what the Pocket Cubes at that time looked like. And since then, you're probably aware that there's a pretty big market on that. But the final picture here I want to tell you about, and a lot of you maybe worked in a university, the way I found to get students involved was you had a particular evening that they had to come, and they met with our mentors, okay? Now, the mentors could advise the students, but they could not build anything for them, but they would advise them. So how did I keep everybody coming there? You see it. I bought pizza. That's how to get ham radio guys. If you provide pizza, they'll come and be your mentors. Okay. Okay. AMSAT, thank you very much for helping us building the satellites. And Nick and I have got another idea that we talked about. So we can't quit putting those little things up because they're so good for education. Thank you.